We're always taught that the universe is made of these tiny little building blocks. But what if that's not really the whole story? What if that really powerful metaphor is actually, getting in the way of a much deeper truth? Today, we're going to deconstruct one of the most fundamental ideas in all of science. Right, this is the picture we all have in our heads, a universe built from these fundamental little pieces, kind of like Legos. It's this neat, tidy cosmos that we can take apart, understand, and then put back together. It's literally the foundation of how we think about the physical world. But what happens when we start to press on that foundation a little bit? When we ask the next logical question, the one that simple metaphor is just begging us to ask. Let's take a look at what these building blocks are actually made of, at least according to the models themselves. I mean, it seems like a perfectly fair question, doesn't it? If you have a block, you should be able to ask what the block itself is made of. But when we pose this question to modern physics, the answer we get is, well, it's not what you'd expect. It's an answer that really starts to unravel the whole idea. And there it is, our solid, fundamental building blocks. They're described as fields of numbers or whatever. That casual little phrase, or whatever, that's a really profound admission. It tells us that right at the very heart of the model, there's this vagueness. This is not the solid stuff we were promised. Exactly. You'd expect some kind of complete machine, right? Something tangible you can point to. But what we get instead is a mathematical abstraction. And that is a huge clue that the theory itself isn't even trying to give us a final, substantive answer. It seems perfectly content with placeholders that just work. And this is the radical idea that changes everything. The universe has no need for building blocks. They do not exist in reality. It suggests that maybe our whole search for some ultimate, indivisible little component might just be a projection of our own way of thinking. Okay, this slide really gets to the heart of it. The whole concept of building blocks isn't necessarily wrong, it's just in the wrong place. They aren't a feature of objective reality out there, but they are an essential feature of our model of reality. That perspective that we construct to make sense of everything. So this brings us to this great divide, the universe as it actually is, and the story we tell ourselves about it. Let's dig into how this distinction gives us a totally new way to understand what science is really doing. So what do we actually mean by our perspective of reality? Well, think of it as the world filtered through our minds and our scientific models. It's a system that's designed to be useful, to make really accurate predictions and to tell a coherent story. Its goal isn't to be a perfect mirror of what's really out there. This chart just lays it out so clearly. On the left, you've got objective reality, the universe as it is, which might not be neatly broken down into little pieces at all. Then on the right, you have our perspective, where concepts like particles, objects, and laws are the tools we use to build a predictive model. The real takeaway here is that our perspective doesn't need that complete machinery to be unbelievably powerful. Okay, so if the goal of science isn't to uncover the ultimate objective truth of reality, then what is it for? This really reframes the entire scientific enterprise. It shifts the goal from mirroring reality to modeling it. So how do you actually build a scientific model? Well, it's this really beautiful, pragmatic process. First, you just define some abstract things. Call them particles, fields, whatever you want. Then you set the rules for how they interact. You write those rules down in the language of math. And if it all works, boom, you've created a framework that makes some stunningly accurate predictions. And here's the kicker, the really wild part. Our models are so powerful precisely because they're incomplete. They don't get bogged down trying to be a perfect literal map of reality. Their only job is to be predictively adequate. Their usefulness is completely separate from whether their little components are real in some ultimate sense. And this changes the very definition of what it means for science to be successful. A successful theory isn't one that finally tells us what a particle is. Nope. It's one that gives us a mathematical framework that organizes what we see and accurately predicts what's going to happen next. It's all about predictive power, not some grand revelation of ultimate truth. It's about what works. So, after taking apart our most basic metaphor for the entire universe, we're left with one final essential thought, a thought that really reframes the whole quest for knowledge. This is really the core insight of this whole explainer. Science doesn't just hold up a mirror to nature. It hands us a set of incredibly powerful tools, lenses, maps, blueprints, that let us build a coherent, functional, and deeply human perspective of the cosmos. It's not a reflection, it's a construction. And so that leaves us with this question to chew on. Are we really on a journey to some final, ultimate truth? Or is the point of science the journey itself? The endless process of refining and improving this powerful, predictive, and uniquely human story about the universe. Maybe the point was never to find the final building block, but to just appreciate the act of building itself.